Hi folks, this is Jeremy. I wanted to cover a new problem type with you today. It's called partitive division equal shares. Now, we've seen partitive division problems before in the curriculum, and that is simply the most straightforward form of division where there's a number, right, or quantity, and then it's being shared out amongst a certain group, right? So it still has that same relationship where you're trying to find the quotient by doling things out, right, or sharing them. Now, today we're going to look at it is where the shares are fractions. So I'm going to walk you through a problem. We're going to show the different strategies that kids might use, and then we'll talk a little bit about the ways that those strategies become more and more sophisticated. So let's give it a go. So get this into focus. All right, so our problem here today is that Sherelle and Tyrone got 7 brownies at school. Their teacher said that they could have the brownies as long as they each got the same amount. And so our question here is, how many brownies would each of them get? Now, the important part to know as the kids get more and more sophisticated in their strategies is that they start with the idea of creating equal shares, but they might not use everything up. All right, so let's look at this first strategy here. All right, so we have the 2 characters, Sherelle and Tyrone, and then we have the 7 brownies. All right, and the student then says, all right, Sherelle gets 3, Tyrone gets 3, but it wouldn't be fair if they gave one of these to another individual, because one would have 4 and one would have 3. So the student says that each person gets 3 candy bars. Now, this strategy is that there's no coordination between the number of shares and the number of sharers. What they did do correctly, though, is that the student understood that they needed to have the same amount, right, according to the task. And so each of them gets 3, right? Some of us might think about this as 7 divided by 2 with a remainder of 1. But since it's a brownie, we could definitely cut it. And so while this strategy has some viability to it, it's not totally correct. Now, another strategy that students might do, very similar, is they might just give the extra brownie to one of the students because their goal was to use it up. Now, they've used everything up, but now it no longer satisfies this idea of having the same amount. Right? So that's the first strategy. We'll call that creating equal shares in the first go, but didn't use everything up. And in the second version of that strategy, they use everything up, but they did not create equal shares. So now let's move forward to strategies where students actually do satisfy the demand of the task, right? So similar strategy where the student represents both of the characters from the story. And in this case, the student would create a very similar model. And that's 7, right? And they would dole out those, right? So gets 1, gets 2, gets 3, right? And then now let's give Tyrone 1, and give him 2, and we'll give him 3. Now the student considers what they could do with this last one, and they break it up into fair shares, into halves. give each of those out. Now, this student would say that each person gets 3 1/2 brownies. Now, it's important to recognize that if a student has not yet been exposed to fractional notation, they can still deal with fractions. Most, if not all, kids understand that when you break one unit into equal shares, your result is 2 halves, right? So they might not be able to write the fraction, but they might be able to say half. Asking kids what the size of that piece is after they broke it up is a great way to get them identify that half is a number. So that's another strategy that kids might use. Now, students also might use a trial and error coordination strategy. So let's see what that might look like. All right. So again, they might be thinking about the two students, two characters from the story, Sherelle and Tyrone. They still set up those 7 brownies. But this time, instead of doling them out, they sort of say, all right, let's say that I keep going Sherelle, Tyrone. All right, so Sherelle's got 1. They each have 1. Let's do Sherelle and Tyrone again. All right, each of them can get 2. Let's keep going. Sherelle and Tyrone. Each of them can get 3. But whoops, they can't each get 4. But now the student realizes that they have 1 left over. And so they're going to cut that in half. And that's for Sherelle, and that's for Tyrone, right? And so we look at this and we might say that this is 3 1/2. And again, a student might not have fractional notation yet, but they still can understand that that's an equal share or a half of 1. So their answer again would be that each person gets 3 1/2 brownies. All right. So now we've gone over 4 different strategies so far. And now let's look at some more sophisticated strategies. After students have some experience with these top problem types, they might realize that they can actually start to coordinate the number of shares with the people sharing. All right. So for example, they might realize that there are 2 people and they'll coordinate the number of sharers first. Let me show you what that might look like. Let's see if we can get our focus back here. Sorry about that. Here we go. Back into focus. Let's see if that works. There we go. Thanks for your patience. So now the difference here is that they're not doling out, they're not using trial and error, they're actually thinking about the number of people who are sharing from the start of their strategy. So they might say, all right, so if I'm going to share out all of these equally, what I could do is just think about how 1/2 is going to one person, right? So each time, all right, I'm going to take a half of that and I can give that to, let's say, Tyrone. All right, so they can do the same thing here. They'll do the same thing again. And they're taking care of each whole by considering how many people are sharing each of those wholes. All right. So this person knows that Tyrone is going to get 1, 2, 3, 4, 5, 6, 7 halves, right? Now, they might not know fractional notation, but the number for that language is 7/2, right? Another way that a student might be able to combine those is that they might add those up, right? And by putting them together, they could combine this half with this half to get 1, right? This half with this half to get 2, this half with this half to get 3, and then they'd have a half left over, so it could be 3.5, right? So that is called additive coordination, and they're going one at a time, unit by unit. So now let's look at when the student uses additive coordination with groups of items, all right? So let's think about this for a moment. Right? They're going to think about still 2, 3, 4, 5, 6, 7, and our 2 characters. Now they're still thinking about each of them, right? If we think about, there are 2 halves here. There are 2 halves. There are 2 halves. There are 2 halves. I'm just going to split these down so it shows that there are 2 halves, right? Same thing here. And 2 halves. And 2 halves. Now, the reason that this is different is because the kid is actually thinking about them as 2 already, right? They're not counting by halves. They're counting in groups. But they had considered how many people there were in the first place. And so they thought about making sure that they would have enough for all of them in the end. So it's 2 halves, right? And now, if we think about this, we have 14 halves, so each of them is going to get 7, right? So each person gets 7 halves, right? So there are 7 halves for each person. Now, when a student starts to understand what's happening here, right, that the number of items and the number of people sharing those items is a relationship, right, where it's 7 shared amongst 2 people, or 7 halves in this case, then the student might understand that fractions are division, right? So this kid might say, all right, I'm going to do 7 divided by 2 equals 7 halves. Now, if you ask them to think about that in a simpler form or not as an improper fraction, then they're probably able to convert it because they understand that how many times does 2 go into 7? Well, it goes in 3, and then you have a half left over, right? So it goes in 3.5 times. So that is called the multiplicative coordination, right? The fraction is the quotient, right? So what we have is 7 being divided by 2, and this fraction that's made up of 7 divided by 2 is 7 halves, right? Or if we simplify it further, it's 3.5. Last but not least, and this is pretty sophisticated, is that students start to realize that there is actually a ratio being formed between the shares and the sharers. So this is pretty awesome what'll happen here. So we've got 7 and we've got 2. All right, and the student starts to realize that they're just basically splitting that whole total up into 2. And then they figure out, all right, so there's 3.5 on this side and there's 3.5 on this side, right? If it's 2 for every 7, it's 1 for every 3.5, right? So those are the different strategies that you'll see from least to most sophisticated. Now, of course, our strategy is, almost all of our strategies were represented by the number sentence or the equation 7 divided by 2, we'll say equals S, which is the number of shares. But we can also think about this multiplicatively, right? Because they are inverse operations. So students might be thinking about 2 times S is going to have to add up to 7. So 2 times the number of shares equals 7. The most important part to think about when you're considering all of these cool strategies that students might do is that they're coming to this, especially when they're in grades K to 2. We have kids work on these in first and second grade. They're coming to this problem without having had much formal exposure to fractions. But what they do have is they have a strong understanding of what an equal share is, right? And so if we allow students to problem solve and approach it with their own understandings, right, then they're more likely to develop a solid understanding of fractions even before they learn fractional notation. All right, thank you all, and I'll talk to you soon.